These will be the notes for the beginning of Chapter 6. Chapter 6, Section 1, 6.1. Let me be honest about this particular chapter. The chapter itself is very simple, especially if you will follow my notes and what I'm doing. If you don't follow my notes and you have to use the Help Me Solve This button and do it their way, it's going to be a lot longer and more laborious. But my way is pretty simple. But 6.1 is by far the most difficult of the sections. So let's go ahead and begin. This is matrix solutions to linear systems. So this is all matrices. So the very first thing that we're going to do is we're going to have a matrix. We're going to have a system of equations. So here's our system. And we're going to use that system and build a matrix. So we're going to build what's called an augmented matrix. This system is what we would call a 3x3 system because there are 3 different equations and they have 3 variables, x, y, and z. But when we build our matrix, we're going to build a 3x4 matrix because we're going to include the answers in that matrix as well. So this is what your matrix will look like. It includes just the coefficients. So I put 3, 1, 1. That came from the x column. 1, 1, and 3, that's my y column. 2, 2, and 2 came from my z column. And then here's my answers. Now when we plug it in our calculator, we won't have this dotted line, but when you look on the computer or in a textbook, they kind of put a dotted line or sometimes just a solid line there to indicate that the ones on the right are in fact the answers. Now, once we have a matrix, there's lots of different things that we can do with matrices. The first thing we're going to focus on are row operations. So here are the possible row operations that you can do with a matrix. You can exchange rows, meaning I could just switch row 1 and row 3 if I wanted to, or switch row 2 and row 1. I can multiply my rows by any non-zero number. I could multiply them by 3. I could multiply them by -100. I could multiply them by 1/4. So you can multiply them by anything as long as it's not 0. You cannot multiply by 0. And then the last thing I can do to a row is I can multiply a row by a non-zero and then add it to another row. So those are the operations that I can perform to any row in a matrix. Now, the reason why we would do this, we'll get to in just a minute. But the first thing we want to talk about is what it actually looks like when we perform a row operation. So here is my matrix again. And I am going to indicate what row operation I would like to happen. So I have row 1 with this 2-sided arrow, row 2. And that indicates that I want to exchange row 1 and row 2. So my new matrix will just look like this. 1, 2, -3, 5, 3, 18, -12, 21, -2, 3, 4, and 6. So I just exchanged row 1 and row 2. So that's one of my row operations that I can perform. The second row operation that we talked about was multiplying any row by a non-zero number. So the way that would look would be like -2 or 3. Now when I see something like that, I'm multiplying row 3 by -2 and I am replacing row 3. So my first 2 rows, nothing is happening to those 2. They're staying exactly like they were. But row 3, I'm going to change. So it's going to become +4, -6, -8, and -12. Because I just multiplied row 3 by -2 and I replaced row 3. So that was the second row operation that we talked about. And then the last row operation that we discussed was multiplying a row by a non-zero and then adding that to another row. So the way that would be indicated would be something like negative 1, row 3, plus row 2. Now, whenever you see something like this, while I am using row 3, I am only replacing row 2. You always replace the second thing listed. So row 1, nothing is happening with row 1 at all, so it's going to stay the same. And even though I'm using row 3, it's going to stay the same. So I'm going to go ahead and write it down because nothing's changing about it. Now my operation says I am to multiply row 3 by negative 1 and then add it to row 2. So let's see. Negative 1 times negative 2 gives me positive 2. I'm going to add that to this, and that would give me a positive 3. Negative 1 times 3 is negative 3. Add that to 2, and you get negative 1. Negative 1 times 4 is negative 4. Add that to negative 3, and you get negative 7. Negative 1 times 5 is, negative 1 times 6 is negative 6. Add that to 5, and you get negative 1. So that's the last row operation that we discussed. On the next video, I'll explain why you need row operations.